Hello guys, welcome back to my channel. So in today's tutorial we're going to continue with our data cleaning series. So in today's tutorial we're going to go over categorical encoding. So let me just show. Assume you have this data set, right? You're trying to train a model basing on this data to predict maybe the weight. Okay, so if you're given the mango, it will be able to predict the weight of the mango, right? So maybe you're trying to do such a system like that, or you have a data set that has text in it. Now machines usually do not understand text, right? Machine do not understand text, like computers only understands ones and zeros. So if you give it a text data, the computer will be confused as to how to train the model, because most machine learning models, almost all machine learning models, do not work with being given actual text data. They are given numerical values such as 1 and a 0, and then they're able to train on that, especially neural networks, right? So if you have a data set that contains text, you need to transform the data set into, or that feature into a form that the machine can understand, or the machine model can understand. So to do that, we call that categorical encoding. And there are two forms of categorical encoding. There is label encoding and hot encoding. So let's say that we have a female, right? We have a feature in our data set. Let's imagine imaginary data set whereby we have a gender column. In a gender column, there can be either male or a female, right? So instead of writing male and a female in form of text, we label encode that. So let's say that male will be 0 while female will be 1, since computers, they start counting from 0, right? So we have these ones and zeros, whereby 0 is male and 1 is female. So we can transform the data into that format, because ones and zeros are numbers and computers can understand numbers. That's what we call label encoding. So in this tutorial, we're going to go over the two forms of label encoding, which are label encoding, and then sorry, we're going to go over the two forms of categorical encoding, which is label encoding and hot encoding. So there's some traditional there's some machine learning models that by tradition can handle text, and for example is a cat boost model, but you're not going to go over that. And most models do not work with text data, so it's very important that you understand what categorical encoding is. So these labels that have categorical data, such as male and female, in form of text, we call them categorical data. So categorical features or categorical columns, whatever you feel free to call them. So I have it. Let me just go ahead and create this way we left off from last time, where we're dealing with missing values. So let's go ahead and create a new Jupyter notebook, and inside of this notebook, that's where we're going to write the code for all of this. So we're going to go over feature encoding. Okay, so I talk about categorical columns, whereby these are columns that have category. Maybe let's say that you're having a data set for cars, right? And the color for the car can be red, green, or something like that. That is a categorical column. So let me just copy that, and let me go in here. Let me just name this to be let's say that categorical encoding, just like that. So we have categorical encoding, and let me just put it here. I'm just make it a markdown, and I'm going to say categorical encoding, just like that. So in here, I'm going to go ahead and import the two basic libraries which we need, which is Numpy and Pandas. So I'm going to go ahead and say import. Let me just import Pandas as BD, and then I'm also going to import Numpy as NP. So once I have those two imports done, I want to go ahead and create this data frame right here, so we can use. So I'm just going to copy this code and just go ahead and paste it here. Again, if you are new to Pandas and how to create a data frame like this, I have a whole series on Pandas on my YouTube channel, so feel free to check that. So once we have this, I just want to go ahead and print that. So let me print it, and you can see we have this data frame right here. So the first thing we're going to go over is the first method of a label of categorical encoding, which is called label encoding. Label encoding is the simplest form of categorical encoding, meaning that it's for example, we have let me just assume a column in which you have male and female, right? So it will assign 0 to male and then 1 to female, and then in case there's any other gender, let's say there's another gender, then that gender will take in 3, and then if there's any other gender, will take in 2. So it has this running sequence that we have. So it takes the data and then simply converts it into a numerical format, whereby each value after the first encoding will be an increment of the previous one. So if male is 0, then female is 1, then the third gender will be 3, and the fourth will be 4, and goes on like that, right? So that's we have something similar to that. That's actually what label encoding is. So let me show how you can do label encoding. In this, for example, in this data set right here, we have data frame right here. We have a feature to encode, which is this categorical column here, but by default let's check if it's actually categorical column. So we're going to do df.dtype. so this is going to return to me the data types of each column. So you can see the fruit column is actually being treated as an object rather than a categorical column. So what I want to do, the first thing you need to do whenever I get a data is check the data type, and if it's not categorical, most of the time it will be object. So we have to go ahead and convert this into categorical. So I'm just going to go ahead and convert this into a categorical feature. So I'm going to say df, and I'm going to refer to the fruits column, and this fruits column, I'm going to say df, and I'm going to refer to the fruits column again. So I'm going to say fruits, and then I'm going to say .as type, and then the type, I'm going to say the type is going categorical, just like that. So once I have this, I can simply go ahead and run this. So I seems to have an error here, so let me just go ahead and see this. So it's actually category, not categorical, so my bad, is category. Let me get that right. So once we have that, if I do df.as type d types, and then simply run this, I can see now it's a categorical column. So it has been converted into a categorical column. So great. Once we have this here, once we have this being a categorical column as a data type, we can simply go ahead and use label encoding on this. But for label encoding, you can do this in Pandas, or you can also do it in scikit-learn. But the first thing I'm going to show you is how to do it in Pandas. So let me just go ahead, let me just make a, let me just say here, label encoding in Pandas. Okay, so I'm going to show how to do this in two ways. The first way is using Pandas. So to do it, I'm just going to create a new column, and if you're new to how to use data frames and how to add new columns, I have a whole series on Pandas on my YouTube channel, so feel free to check that. So I'm going to say encoding with Pandas, and this is going to simply going to be df. I'm going to get the fruits column, so I'm going to say fruits, and then I'm going to say .cat codes. So this is going to add to us a new column, and this is going to be the categorical column. Okay, so if I do a df right now, I can see I have a new column right here, which is a categorical column. So it has converted this and has a textual representation of this. So whenever you're referring to one, whenever you're referring to grape in our model, you'll be using 1. Whenever you are referring to pineapples, you'll be using a 4. Whenever we are referring to apples, it will be using a 0. So you can see it encoded all of this info in this format, and you can see it follows the alphabetical ordering system, right? So that's what label encoding is, just converting a text into numbers that a computer can understand. There's another way of doing scikit-learn. So let's go ahead and try to do this in scikit-learn. So I'm just going to go ahead, I'm going to say from sklearn, I'm going to import sklearn.preprocess, so .preprocessing, so the preprocessing. I'm going to go ahead and import, I'm going to call label encoder. Okay, so once I have that imported, I need to create an object of this. So I'm going to say label encoder, and this is going to be an instance of the label encoder, that library class that we just imported. So once we have that, you can simply go ahead and fit this label encoder. Fitting is basically training this label encoder to encode these values right here. So to encode this column right here. So what I'm simply going to do, I'm simply going to say label underscore encoder dot fit. So fit, I'm just going to say fit takes in the data frame, and which column are we talking about? I want to fit in the fruit column, because it's the only categorical column that we have, because this is actually a numeric value, and also this is a numeric value. And you can also check that here. Let me just do this df.dtypes just like this, and you can see this is the only categorical column that we have, and you did the conversion right here, because by default text will be object in Pandas. So once we do this, it's going to train on this column, and it's going to understand how to fit those that column, and how to transform this column into a format like this. So that's what fitting does. So now we can just go and say df create a new column, and I'm going to call encoded with sklearn, just like that. And this is going to be this is a new column, and it's going to be label encoder dot transform. So instead of transforming, you need to provide in the data frame that there are series that you want to transform, and I simply want to transform the categorical column of fruits. So if I run this and I come down here and do a df, you can see I have that there. So it has been encoded as well, and you can see these two encodings are very similar, and they all follow the alphabetical order. So that's how we can do label encoding in Pandas, or in using Pandas. But using Pandas and scikit-learn. So that's all that there is to label encoding, just converting the categorical value into a textual into a numerical value that a model can understand, right? Because a model can understand these numbers that we have here instead of apples and grapes. A model a computer doesn't understand text, right? But the computer can understand numbers. So once we have that, but one of the disadvantages of a label encoding, I want to talk about the disadvantage before we move on to one-hot encoding. The disadvantage of label encoding is that whenever you're using label encoding, for example, you can see that apple has 0, grapes have 1, pineapples have 4, oranges are 3, and then mangoes are 1. So one of the disadvantages of this is that the computer will assume that these are actually hierarchical numbers, meaning that an apple has 1, and a pineapple has 1, and 1 is greater than 4. So a computer might assume that a pineapple is greater than an apple, or a pineapple is greater than an orange, or an apple or a mango, which is not true, right? These are just fruits and we are not putting any category on them. So this is one of the disadvantages of using label encoding. It has this assumes this categorical ordering of the data, which we don't actually want, because you're not trying to tell the computer that an apple is less than a pineapple. That's not what you're trying to do. We're just trying to convert the data into a format that the computer can understand. So this is one of the disadvantages of using label encoding. And whenever using label encoding is based when you use label encoding when you have only 2 columns, meaning that, let's say, gender, you have only male and female. That is when you can use label encoding, because it's only either 1 or a 0, right? A true or a false. That way the computer will not assume any hierarchical ordering of those values, right? But whenever you have multiple categorical values, like in this case, you can see we have this of 4, 3, and 2, and all of these numbers, right? This makes the computer assume that there's a form of categorical ordering to this value, which is not what you might intend to do, right? So this is one of the disadvantages of using label encoding. So a way around label encoding is using one-hot encoding, and this is what you're going to go over. So let me just create another solid in here, and let me just say this is going to be one-hot encoding. So in one-hot encoding, it solves the problem by instead of this hierarchical assigning these hierarchical values, it solves the problem by creating multiple columns. In this case, we have 1, 2, 3, 4, and 5, right? 5 rows. So it's going to create 4 columns, right? And in 4 columns, it's going to use that to it's going to only put 1s and 0s inside of those columns. And let me just explain to you. It can be a bit tricky to understand. So let me just go ahead and make a simple explanation for you. So I'm just going to go ahead and show you how to do one-hot encoding in sklearn, and when I do one, and when the results comes out, I'll show you what it actually means. So I'm going to go to from sklearn.preprocessing. I'm going to go ahead and import one-hot encoder, just like that. So once I have the one-hot encoder, I'm going to create an instance of this. So I'm going to one-hot encoder. One-hot encoder, and one-hot encoder is going to be an instance of this. It's going to be an instance of this class right here. So create this and then run that cell. So once we have that, you can simply go ahead and transform this data. So I'm going to say transformed underscore one-hot encoding, and this is going to be equals to one-hot encoding, which is this object right here. So I'm simply going to copy it and paste it here. So paste it there, and then simply I'm going to do fit underscore transform. So fit transform is going to fit it and then transform it. On this other way, we did it on 2 different ways. We fit it first and then later we transform it, right? So doing fit and transform will do all the same thing in the same line. So you can also try to use fit and transform here, and it will work as well. So what I simply want to do in fit and transform, I want to provide the series in which I want to transform. It's called fruits, right? Which is the column I want to deal with. So it's called fruits. So once I have that, I can simply go ahead and run this. So I can simply go ahead and run this. So I have an error here, so I think I need to put in 2 columns right here. So let me just put in another square bracket. So once I have that done, I can simply go ahead, and if I print this, it's just going to tell me it's let me just copy this, paste it here, and then print it out to get back this parse matrix. Okay, good. So whenever using one-hot encoding, you don't get one matrix or like one vector, you get a collection of vectors that make a matrix. So I'm going to say one-hot encoding underscore data frame is going to be equals to pd which is pandas.data frame. So I'm going to convert this parse matrix into a data frame. So I'm going to pass in that, and I'm going to simply dot to array, it's going to convert to array, and I'm going to say the data type, and it's going to, the data type you can just say is of type int. So if I run this, the to array is undefined. So let me just go ahead and check if I got this right. So this is actually a dot right here, so my bad. So if I run this and I try to print this out, so let me just print it out right here, print this out, so you can see we have this right here. So it has transformed that into the columns that we need. So it took these numbers, right, this mango, apples, and oranges, pineapples, and grapes, and then transform that into a series of columns, and this is what you're going to use to train the model on. So you train the model on this matrix rather than using these apples, mangoes, and text data, or instead of using this hierarchical data, you train it on this. Since this only consists of ones and zero, which is either a true or a false, then the model work fine. So for grapes, you can see for grapes it has been 0 and then 1 and then 0 0 0. For apple, which is the first one, apple has a number of 0, right? So it's the first one. You can see apple here, it has 1 and then 0 0 0, and then grapes is the second one, it has 1, it has 0 and then 1 0 0, and then the third one is oranges, and oranges will be right here. So it has 0 0 0 and then 1 and then 0. So it goes like that, and you can use this to train your model, and that is what we call one hot encoding. So let me just explain this to you. Let me just join these two data frames so that you guys can understand. So I'm just going to say one hot encoding underscore final underscore df, and this is going to be equals to df.join, which is the original data frame, dot join it to one hot encoding underscore df. So if I run this, and I can simply go ahead and print this out right here. So I'm just paste this one and print it out. So you can see we have the one hot encoded feature column right here. So you can see these are the one hot encoded features right here from 0 1 2 3 and 4. So these are the one hot encoded features. So great. So once we have these features, there's also another way to generate this one hot encoding in Pandas, and we can simply generate this in Pandas using using the dummy variables, and this also can be referred to as dummy variables. So you can hear people calling these dummy variables. They're just referring to one hot encoding. So let's go ahead and do that in Pandas. So let me just go in here. I'm going to go ahead and say dummy underscore data frame. Okay, sorry, dummy underscore data frame. And in dummy data frame, we're going to say pd.get underscore dummies, get dummies, and you need to provide in which series you want to get a dummy. So this is going to be the fruits column, and then you want to prefix this with let me just run this for now so that you guys can see. So if I run this and I try to print out the, let me just copy this and try to print out this, or print out this, you can see we have transformed all of that into these values right here. So an apple will be 0 and then 1 1 0, and you can see that format right here. So we can go ahead and actually give it a prefix. So you can say prefix, and the prefix can be underscore, it can be let's say fruit, let's say fruit underscore type, just like that. And then you can actually specify which column. Now let's just go and actually run that for now, and you can see we have this data right here. So you can see fruit type underscore, the first one is apple, and then oranges, and then stuff like that. So all these have been encoded, and to demonstrate this to you and show how the encoding works, I'm going to simply go ahead and let me just bring this right here. I'm going to copy this and I'm going to change its style. So I'm going to paste it here, and I'm going to say style, and the style is going to be, I'm going to say style.apply, and I'm going to apply map. So in here, I'm going to simply say, I'm going to take a lambda function. I'm going to take in lambda, taking x, and then do the following. I'm going to say background, and then the background hyphen color, just like we have in CSS, right? It's going to be yellow. I also want the background going to be yellow if x is greater than 0. Okay, so if x is greater than 0, then it's going to be this is actually a ternary statement. So if x is greater than 0, then you're going to apply this mapping of the color being background color being yellow. Okay, else let me just give it a space there. So I'm going to say else, and then else you're going to say the background hyphen color, the background color, and the background color should be blue. So I'm going to go ahead and run this, and if I do by the dummy variables, let me just copy this so you can see we have it right here. So you can see that we have the different coloring right here. So we start with from apple, which is here, and let me just go ahead and actually get the data frame. So you guys simply do a df, and then I can print it out here. Yeah, so you can see we have a data frame, and apple being 0, so it starts from 0, right? So you have 1 and then 0 0 0 0, and then grape is mango is for number 2, right? So it goes 0 0 and then 1 and then 0 0 0, and then we have the grapes which are here, so it goes after the apple we go to grapes, right, which is 0 1 and then 0 0 0, and then we go to the mangoes, which is going to be on the very first line, which is 0 0 and then 1. So you can see apple will be having a 0 on the first row, and then all the others will have 1 on the first row. We have 1 on the first row, or on the first column of the first row, right, which is this one here, to have 1 on the first column, and then all the other columns will be 0. And then grape will have 1 on the second column, and all the other columns will be 0. And then mango will have 1 on the third column, and then all the other columns will be 0. And then it goes like that, right? Oranges will have 1 on this column, and then all the columns will be 0. And then finally pineapples will have 1 on the very last column, and then all the other columns will be 0. So that's how we can use categorical one-hot encoding. So the advantage of one-hot encoding compared to label encoding is that it doesn't suffer from that hierarchical assigning of value, because here there's only ones and zero, which is basically a true or a false. So a computer, the model will not see any hierarchical ordering of the values. So whenever you want to label encode something that has more than one categorical values, instead of using one-hot encoding in which you give hierarchical ordering to the values, you want to use label encoding. We want to use one-hot encoding, which will not give a categorical hierarchical ordering to the values. Okay, so that's all I wanted to talk about in this video. So thanks for watching, and see you in the next one. Keep safe. If you enjoyed this tutorial, kindly consider subscribing to the YouTube channel. That's one of the ways you can support me and keep me motivated to keep making these videos. So thanks for watching, and see you in the next one. Keep safe.